In this problem, we're given a function and we're asked to find the derivative of the function and then to simplify the result. In this particular function, I always look through here to see what I'm dealing with. This is a polynomial. It's been partially factored out here, and because of that, I've got a couple of options. I could choose to multiply everything out, and then the derivative would be fairly straightforward, but it would take a little bit of time to multiply out the x squared plus 2 to the fourth term. And of course, once I did that, I have to distribute through the 4x minus 3. So rather than go through the algebra in the beginning, I think I would go ahead and use the product rule on this right there. The derivative then, according to the product rule, is going to have 4 pieces to it. It's derivative of the first times the second plus the first times the derivative of the second. And before I go ahead and calculate each of these entries here, I'm going to talk a little bit about the simplification that will come afterwards. As I think about finding the derivative of each of these parts within the product, the observation that jumps out at me is that this second piece is going to require a chain rule. There's going to be a chain rule on the derivative of the second piece. And because of that, I can predict that in the simplification step, one of the key steps will be to factor out some x squared plus 2's. There will be some over here and some over here. And in fact, there will always be one less than you started with when you chain on using the generalized power rule on a portion of a product rule. So the work as I see it laying out here would be calculate these derivatives, and then the simplification will involve factoring x squared plus 2's. So I calculate this derivative. I see that the derivative of this first part is 4. I'll leave the second part alone. So I've got an x squared plus 2 to the fourth, and then I leave the first part alone, 4x minus 3, and then I carry out the chain rule, which is our generalized power rule. So the derivative of a function to a power, you bring that exponent down, leave what's inside alone, reduce the exponent by 1, some x squared plus 2's. I've got 4 on this side and 3 on this side, so I'll go ahead and factor out 3, and then I use a square bracket just to keep track of things in my mind. It's really just a parenthesis, but what's left over now on either side of this plus sign is what I need to fill in. I've pulled the 4 and the x squared plus 2 cubed, so I've left one of the x squared plus 2's behind. And then this is the plus sign from within the product rule. And on the right side, I've pulled the 4, and I've pulled out the x squared plus 2 cubed. So what I'm left with is 4x minus 3 and 2x. Alright. So the majority of the factoring is done. Now what I do is go through and clean up what's in these square brackets, this last leftover portion. I'll distribute the 2x through this piece, which will take much less time than if I had tried to distribute in the very beginning, and clean up whatever is left in there, combine like terms, and think about factoring the result as well. So passing through here, I've got an x squared, a plus 2, and then there will be an 8x squared, 2x times 4x, and then minus 6x. And one more pass, I will combine like terms, and I like to write the highest order term first on down. So I've got an x squared and an 8x squared, which is a 9x squared. I've got a minus 6x from there, and a plus 2, and that's it. So now I would look at this and ask myself, can anything be factored further? Well, the x squared plus 2 cannot be factored. This is never 0, so there are no real factors. It could be factored in the complex plane, but there are no real factors here. And this one, looking at it, the factors don't jump out at me. I might quickly calculate b squared minus 4ac, that part of the quadratic formula that would tell me whether or not there were real roots here. And I don't actually have to calculate, we can just talk about it. In here, the b squared would be 36, and I'll subtract 4ac. 4 times 9 is 36. 36 times 2 is 72. So it'll be 36 minus 72 under that root. That means there are no real roots here. The discriminant would be negative, so this won't factor, is what that's telling me. And so this would be the simplest form of that derivative. This is f prime. When we're using the derivative, one of the things we're often looking for is critical values, places where that derivative is either 0 or where it doesn't